Hello everyone. A tree is 8 kilometers due south of a building. Ayo is standing 8 kilometers west of the tree. How far is Ayo from the building? This is a very simple question. Okay, so means there's a building, right? There's a building. Let's say the building is at this point, and in bearing, every point, of course, has a north pole. So north is over here, right? And then of course, you have your west here, east, then south. So recall that a tree is due south. So let's come 8 kilometer due south, 8 kilometer to this point of the tree. So the tree is over here. Ayo is standing 8 kilometer west of the tree. So let's come 8 kilometer over here. 8 kilometer. Ayo is at this point. Okay. And of course, every point has a north pole. Okay, so we can just complete the diagram. Yeah. So Ayo is at this point. All right. So, oh, sorry, this kilometer. All right. So, how far is Ayo from the building? This is Ayo. This is a building. How far is Ayo from the building? Now you can see that a triangle has been formed, and a right angle triangle, of course, and here is missing. This is where we want to find the distance. How far is Ayo from the building? Ayo is right here, the building and the tree. So we can easily use Pythagoras theorem to figure this out. Recall that Pythagoras theorem is x squared equals a square plus b square. This is hypotenuse and that's what we're looking for. X squared equals the square of 8 is 64 and that of the 8 is 64. So we have 64 plus 64 to give 128. Then you take the square root of both sides. So x equals to the square root of 128. We can simplify 128 further. Break it down sort of course. We have a perfect square, 64 times 2. 64 is the perfect square, and the square root of 64 is 8. So we have 8 root 2. So this is the distance. This is how far Ayo is from the building. Then the other question wants us to find the bearing of Kofi from the building. Please take note of from the building. So meaning we're going to read from the building. And in bearing, you read from the north, clockwise from the north, right? So of course, this first quadrant is 91 of that. 90, 90, and this angle, which we need to figure out. Okay, X. Now I'm going to identify some important angles here that will help me find this easily. Now look at this. If y is here, then I can assume here to be y alternate angle. This alternate, these are y. This angle is alternate to that. Okay. So and how do I figure this out? I can use trig ratio. I have two sides here. This is the opposite and this is the adjacent. So the trig ratio that brings together opposite and adjacent is tan. So the tangent of y will be equal to 8 over 8, which is 1. So you take the tan inverse of 1. Okay? The tan inverse of 1 will give you y. And the tan inverse of y of 1 is 45. So y equals 45 degrees. Alright, so if y here is 45 degrees, then here is 45 degrees, alternate angles are equal. So then, since the whole of this angle is 90 degrees, and I know this part to be 45, obviously x is 45 degrees. That's just 90 minus 45, that's 45 degrees. So then I can figure out the total bearing. Okay, so the bearing over here, the required bearing will simply be, this is 180 plus 45, and that gives 1 or 225 degrees. So that's the bearing of Kofi from the building. See you guys in the next video. Bye.